The resistors in the following four circuits are identical. Cells are identical and have no internal resistance. Each cell can supply the same total amount of energy at a constant voltage before becoming exhausted. T1, T2, T3, and T4 are the lengths of time after which the cells in these circuits become exhausted. Which comparison of T1, T2, T3, and T4 is correct? So the first thing to notice is that we want to compare the times, and because this is energy and power, we could write T equals E over P. And because they all have similar amounts of energy, or the same energy, we could then just compare the powers between them. But the key thing to note here is that because we're unsure about how 1 and 2 may be compared to 3 and 4, it might be best to separate them first. So let's compare 1 with 2, and then 3 with 4. And then we should also note that there are equal signs in the solutions. So maybe two of these circuits will have the same energy over power ratio. So let's start with 1 and 2. We know the voltage across them is the same, so we just need to compare the resistances. So we have P is V squared over R is the choice of the power formula that I'd use. So because they have the same voltage but different resistances, we can then compare them quite easily. So circuit 2 has resistors in parallel, and when resistors add in parallel, that lowers the overall resistance. So it goes from R individually to 1 over R plus 1 over R is 2 over R, flip that, becomes R over 2. So you should just remember that when you add resistors in parallel, let's say 2 of them in parallel, it becomes R over 2 as the effective resistance. So circuit 2 will have a smaller resistance than circuit 1. So because it has a smaller resistance, it will have a larger power. And because it has a larger power, it will have a smaller time to exhaustion. So T2 smaller than T1. And then we can also look at how 3 and 4 compare, because it's almost identical except the cells are just arranged slightly differently. So we can see from this that T4 will be less than T3 for the same reasons, because T4 will have a smaller resistance, so larger power, so smaller time to exhaustion. And then now we just need to compare whether any of those circuits will have identical times to exhaustion. Well, the first thing I'd notice is that 4 and 1 might actually be quite similar, and we can explain that in this way, that 4, if you could separate it, it's like it has one cell to each resistor. So 4 you could break down into a resistor, and then this cell, and then this one has its resistor, which with its own cell. And that looks pretty similar to 1 actually, because you got 2 of these cells and then 2 of these resistors. And that's going to take the same amount of time as if we just had 1 resistor and one cell, because each one would essentially be getting the energy just from one cell. So 4 and 1 we expect to be the same. So T4 should actually equal T1. And so we know it could be either E or it could be C. But we know that T2 is smaller than T1, and we know T4 is smaller than T3. So the answer must be C. So this is our setup. These are our setups. This must be the correct answer for the times to exhaustion. If you have any questions, please do let me know in the comments. But hopefully this made sense, and why we could compare 4 and 1. That was the key part of this question that made it quite tricky. It's the fact that individual cells of batteries, you could see 1 and 4 have similarities.